All right, so we're going to be factoring one more time. This time, the special cases have to be memorized. All right, so we should know how to do all of these now. So 25, we have a negative 10. So it's x squared, so it's got to start with x and x. It's plus, so they're both the same, and they both have to make a minus. So it has to be x minus x minus. And I think x minus 5 times x minus 5 is x squared minus 10x plus 25. Those are the factors. This one works with a 9, so this is harder, all right? Now, it could be 9 and 1, it could be 3 and 3, all right? Now, let's realize we have a plus 1 there. Here's some advantage. These both have to be plus 1, because that's the only way you multiply to make 1 there. And so we have to turn these numbers in, and everything has to be a plus. I have to turn it into a 6, and I think 3x is going to be more likely to do that. Let's see. 3x times 3x is 9x squared, outer plus 3x, inner plus 3x. Yeah, that's the one, right? Plus 6x plus 1. So that checks. So it's 3x plus 1 times 3x plus 1. I want to erase this just because it's going to be my way later. Okay, and clean that up. Okay, now let's do some foiling here. So this is x squared plus 4x plus 16, which makes x squared plus 8x plus 16. This one in the middle is x squared minus 4x plus 16. So it's x squared minus 8x plus 16. Okay, this one is x squared minus 4x plus 4x minus 16. Those add up to 0x, which is 0. So it's x squared minus 16. All right, so a couple of things. So 3, 4, and 5, we did these. These are going to be special cases. We could write x plus 4 times x plus 4 as x plus 4 squared. And this would be x minus 4 squared, right? And both of those make perfect square trinomials. Okay, the last one does not make a perfect square trinomial. All right, the parts of it are actually perfect squares. X squared is a perfect square, 16 is a perfect square, but the whole thing is not a perfect square trinomial because we're not multiplying the exact same twice, right? And so if you another way to write this answer in number 2, right, because we're going to do numbers 3, 4, and 5 backwards today, we're factoring. Another way to write number 2 answer would be 3x plus 1 squared. Another way to write number 1's answer is x minus 5 squared. Okay, so let's look at the patterns again. We've seen these patterns, now we're seeing them backwards. Right? This perfect square trinomial makes x minus 7 times x minus 7 squared. This one, where it's all plus, makes x plus 7 squared. The binomial, when you see a binomial, we're almost always factoring a trinomial. When you see a binomial and you're asked to factor it, you should be thinking, oh, I've got that special case where it's the exact same thing except for this is a plus and this is a minus, right? Because the way the center term disappears is you end up with something that are opposites and add up to 0. Okay, memorize those patterns. Here we go. All right, so this is a perfect square trinomial. I say that, and when I say that, I am telling you that you have the exact same thing twice. X minus 6 squared. So if I say it's a perfect square trinomial, you must have the exact same thing twice. All right, here's a backwards one. All right, let's double check this one. These are both minus, I believe, right? Because you do that, you get 49 minus 7x plus x squared. So this is 7 minus x, the whole thing squared. It says it's a perfect square trinomial. So that means, right, that we're not doing 9 and 1. We're doing 3x and 3x. We're not doing 1 and 4. We're doing 2 and 2. And it's all plus, so it's plus. So please, you have to read that because that was a lot of clues, right? That you didn't have to do 1 and 9. You didn't have to do 1 and 4 because those are not going to end up with the same exact factor twice. And you're going to write this answer as 3x plus 2 squared. Okay, so now we have x to the fourth, right? We did this forward many times. That means this one's x squared. It's the only way you get x to the fourth there. This is y to the fourth. The only way you get that is y squared. Everything is a plus. Yes, so this is that x squared plus y squared, the whole thing squared. Check it out. All right, with decimals. So we have x and x, and there's 36. So we're talking 0.6, 0.6, 6/10 and 6/10. They're the same with this plus, but they're both going to be minus. And so this is x minus 6/10 squared. All right, it's a square, so both of these have to be the same. All right, so now we're going to do something called complete the square. I'm going to give you part of a trinomial, and you're going to give me the last part of it to make a perfect square trinomial. Now, let's remember all these things we're factoring in are in ax squared plus bx plus c. And on this page, a is always going to be 1, so it's just going to be gone. Okay, so to figure out what c is, where I put the question mark, you're going to take b, which is -8 here. You take b, you divide it by 2, and you square it. That's the missing part. So -8 divided by 2 is -4, and -4 squared is +16. So to make that thing be a perfect square trinomial, you have to put a +16. Nothing else will go there, right? And we're going to say factor the polynomial, and that's to check it. So let's check it. So we have x, right? We have the exact same factor twice, and it's going to be x minus 4, which is x minus 4 squared. Yes, it checks. But the number that completed the square there was 16, and you have to know that. So you have to memorize this little formula. B divided by 2, right? This is ax squared plus bx, so b is right there, plus c. A will always be 1 here. Okay. So again, b is 6, so you do 6 divided by 2 squared. That's 3 squared, which is 9. So to complete the square, the question mark must be a 9. And we're going to factor it to check, right? To be a perfect square, we should have the exact same factor twice, which we do, x squared, x plus 3 squared. So 9 made the perfect square. Okay, now here are the only binomials we're going to be factoring. So every time, right, that's a binomial, and it's the difference of perfect squares. This is a perfect square, that's a perfect square. Turns out the whole thing not a perfect square, all right? And it is the only type of binomial we're going to factor for the most part. So the answer to all those binomials looks like this, okay? So it's x minus 5 and x plus 5. Those are the factors. Done. You can't write that any other way. Well, you could write x plus 5 first, but that's it. It's not a perfect square. It's not the same thing twice. So this is x minus 11, and this is x plus 11. This is x minus 3y and x plus 3y. All right, so then it's a binomial. So we know we're going to have 1 plus and 1 minus. We know we're going to have x and y and x and y. And this must be, they have to be the same numbers, 7x and 7x, 2y minus 2y. So it's 7x plus 2y times 7x minus 2y. Now, any one that's not really easy, I would check it with FOIL. 7x times 7x, 49x squared. Outer, negative 4y squared. Inner, negative 14y squared, right? 7x times negative 2y. Inner, plus 14y squared. Those are opposites. They add up to 0y, also known as 0, all right? And then minus 4y squared. Right? This is x squared and x squared, and one of each, minus y squared and plus y squared. Right? Because if you FOIL that, you get x to the fourth, x squared times x squared, outer, plus x squared y squared inner minus x squared y squared. Those are opposites. They subtract to 0. And minus y to the fourth. Notice this is always a minus here in these binomials. You'll see what happens if it's plus in a second. You get 4 minus x here, then it must be 4 plus x, right? It has to be 4 plus x because this is a binomial, and that's really the only way the middle term drops out. All right, so that was the difference of two perfect squares. All right, so one of these is factorable and one is prime. The sum of two perfect squares is prime. So let's look at this, right? This is x minus 8 and x plus 8. This is nothing. This is prime. And the reason it's prime, if I put this on a test, some of you will say this. But that makes x squared plus 16x plus 64. It doesn't make that, right? So that's why it can't be x plus 8, right? Please. That one on the right is prime. So this one is 2x minus 9 and 2x plus 9. This one is prime, right? Because 2x plus 9 times 2x plus 9 would make 4x squared plus 18x plus 18x plus 81. It would have plus 36x in the middle because it would be a perfect square trinomial. So this is prime. There is no factor. The factors are 1 in itself, right? Just like these numbers are prime. 2, 3, 5, and 7, 11, 13, right? Only multiply to make 1 in themselves. All right, so let's practice. And again, on the homework, there are no prime ones on the front. On the back, I ask you about prime. Okay, so this is x plus 11. These are all the special cases times x plus 11. Please write that as x plus 11 squared. This is 5x and 5x. And we have a 6 and a 6, and it's both minus. So it's 5x minus 6 squared. These are equal for all values of x. All right, to complete the square, you take b divided by 2 and you square it. So b here is negative 18 divided by 2 is negative 9. Negative 9 squared is 81. So to complete the square, it must be 81. All right, and to check it, it would be x minus 9 squared. Here, b divided by 2 is 8, and 8 squared is 64. So it would be x squared plus 16x plus 64, and that would make x plus 8 times x plus 8, or x plus 8 squared. But the number that completes the square is 64. The number that completes the square is 81 there. All right, more practice. All right, this is x minus 1. This is a binomial, right? So it must be this pattern. Right, there's no middle term. This is another binomial. So we have to have this exact same thing where 1 is minus and 1 is plus, so the middle term drops out. This is same thing, x minus 0.7, x plus 0.7. And these were all the difference. Let's write that. These first three were the difference, subtraction. I got to spell the difference of perfect squares. Each part was a perfect square, but the whole thing wasn't. This is the sum of perfect squares, and that is prime, right? X plus 2 times x plus 2 does not work. You get x squared plus 4x plus 4, not this. The sides of this must be x plus 13, I believe, and x plus 13. Good luck with the homework.